Hello, everyone, and welcome to Processing Foundation's Open Assembly 2025. We're so glad you're here. Open Assembly is a global online festival where artists, coders, and educators collaborate to shape a more just and equitable future with technology. My name is Amy B. Woodman, and I'll be your host today alongside my colleagues, Kit Kuxanok and Raphael Ducoville. Go ahead, Raf.
Thanks, Amy. This is our biggest showcase yet with the Processing Foundation Fellows, PROS grantees, and Google Summer of Code contributors from around the world. Over to you, Kit.
Thanks, Raf. So today we're going to have talks, workshops, demos, and performances, all celebrating the creativity and openness that the Processing Foundation stands for. Each person presenting today is a contributor to the open source software community, embodying the ethos of collective creation that drives our work.
So right now, I'd love for everybody to open up the chat and let us know where you're calling in from. Throughout the event, we'd love you to share your thoughts in that chat and use the Q&A feature in Zoom, and then share also photos online using the PFOA25 hashtag. And we'll also invite you to continue the conversation on our Discord today and after the event. This is the URL for the Discord on the screen. We'll also post that into the chat and pin it there. So the first part of our show will feature our technical presentations, and also be sure to stay tuned for the second half of the event where we'll share presentations from our Processing Foundation Fellowship. All right, Kit, over to you again.
Thanks. So this year has been our 13th year of participating in Google Summer of Code. Since 2011, over 110 projects have been completed by GSOC contributors in the P5.js and processing ecosystem. This year, our focus has been on improving the tools for coding in P5.js, and I'm so excited for these three contributors to share their summer projects and experiences.
Great. Our very first presenter is Kamakshi Bali, who has created a context-aware autocomplete tool for the P5.js editor. This feature makes the coding experience smoother and smarter. Her work helps prevent irrelevant suggestions and recognizes user-defined functions. So yeah, let's make some noise in the chat for Cam. Here we go.
Hello, everyone. My name is Kamakshi. I'm 19 years old, and this summer I had the wonderful opportunity to work as a Google Summer of Code contributor with the Processing Foundation. My goal with this project was to create an editor that keeps you in your creative flow and to make coding feel smooth, focused, and enjoyable, and helps you stay immersed in what you're doing without interruptions. Here I have a very simple sketch that creates 2D noise with different parameters. Let's say I want to add more lines of code at the end, right here. But suddenly I forget the name of the variable. Was it scale noise or noise scale? No worries. The autocomplete hinter now suggests that it was noise scale. It reminds me that it was noise scale. Previously, the hinter only suggested P5.js functions, but now it also suggests your own variables and functions, the ones that you defined in your code. This means you don't have to break your focus to go back and check. You can keep coding smoothly and stay completely in your creative rhythm. Now, let's imagine I'm a complete beginner. Suppose I accidentally put the draw function inside the setup function, which is definitely a mistake. The editor now instantly warns me about this. Instead of getting confused or spending time debugging, I immediately understand what went wrong and can fix it right away. This feature helps you learn from your mistakes while staying confident. Now let's talk about context-aware renaming. Let's say I have a global variable called noise scale at line 8, and it's also used again here at line 30. And then inside the draw noise function, there's a local variable with the same name. Now, if I wanted to rename only the global variable, I can just press the F2 button, type the new name, and the editor automatically updates every relevant instance without touching the local one here. As you can see here, there's no need to manually scroll and check where that variable appears. It saves time and effort and lets you focus on your code logic and creativity instead. Another feature is jump to definition. So if I'm working lower down in the code and want to see where this variable was defined, I can simply Control plus click on it, and the editor immediately takes me to that line. Let's take a look at another example. Suppose you declare a P5JS class. Here I've used load XML. Naturally, when you try to access it using the variable that defines it, the editor should be able to suggest the methods that belong to that class. So here, as you can see, when I type my XML dot, the editor now suggests all the methods that are part of the P5 class. And this functionality is not just limited to P5 classes, it also works for user-defined classes. For example, here I've created a custom class ball with two methods, update and display. And when I type ball dot, it rightly suggests me the two methods. This is context aware, smart, and helps you code faster. Another very important part of this project was accessibility. Creativity should be for everyone, no matter their background or physical ability. So all of these new features are fully integrated with screen readers. This ensures that visually impaired users can have the same smooth, uninterrupted coding experience as everyone else. And this was it for my presentation. I'm really grateful to have had the chance to work on these features, and I look forward to continuing to contribute to the project in the future.
We're going to move into a question that Dia, your mentor, has prepared for you. She asks, your project has brought great enhancements in accessibility and developer experience. Compared to professional IDEs that support multiple languages, what features do you think future contributors should focus on developing?
I think future contributors can really focus on bringing in features that make the P5JS web editor feel as empowering as professional IDEs, while still keeping it simple and, most importantly, creativity driven. For example, things like real-time collaboration where you're able to code together, share sketches instantly, or even see live cursors like in VS Code's live share. And then there's always inline documentation and intelligent tooltips. So instead of switching tabs to look up a function, you can just hover on and see a quick description or example right then and there. That also sort of helps you stay in your flow. And finally, more personalization and accessibility options like, say, different themes, layouts, or adjustable font sizes can also help people. It can really make the editor their own and stay comfortable while creating. And then obviously there's always the possibility of integrating AI tools for code completion and make everything easier, but that's a very far-sighted feature.
It's amazing. Yeah, thank you. We really hope that folks are inspired by Cam's work and continue to help contribute to this really incredible feature. Thank you so much, Cam. Well, the next person we have up is Divyansh, who has been working on a translation mapping and accessibility for P5JS. His project makes P5JS more accessible across languages by automatically tracking and flagging outdated translations and helping contributors keep documentation consistent and accurate. Over to you, Divyansh.
Hello everyone, I'm Divyansh, and I was Google Summer of Code mentee this summer with the Processing Foundation, and my project was GitHub Action for P5.js translation tracker. Before actually getting into my project, I would like to give you guys some context. One of the main focus of P5.js, of processing in general, is accessibility. And as a part of accessibility, the our website p5.js is available in 5 different languages, including English, Hindi, simplified Chinese, Korean, and Spanish. So last year, I was a part of this project for p5.js 2.0. We were moving the translation in these 5 different languages. We were part of like around 20 contributors who were working on their respective languages to update the translations across examples, references, and these. While working on this, one main issue is like you had to manually track which all examples or which all documentations are outdated. We had to manually check, and then we had to manually update those things, right? So it was a very tedious task. So yeah, coming back to the problem. So the problem here is that the English documentations or the websites, that gets changed very frequently. That might be a code change, that might be a adding more description to some function or some reference, some tool, some library. So these all were the tedious tasks. So that's why this summer I was involved in making this GitHub action that does these things automatically. So for example, I'll show you this thing. So I'm currently on the English version of this color example. Suppose I wanted to add something in this. I wanted to, add this thing that, okay, color basically adds color to your p5.js sketches. So to edit this thing, I can either fork this whole repo manual on my local system. I can just go to the GitHub and I can go to this particular page on GitHub, which is like the description.mdx file of this color example. And I can just go here and just simply commit, edit this particular thing, the lines that it adds color. And then I click on commit changes and it will basically create a pull request. So since I have already done that, so I'll just show you what will happen when you will actually create a pull request and it gets merged by some maintainer. As soon as you click on them, as soon as the maintainer clicks on merge, so something like this happens. So as you can see, this bot has created one issue, which basically says that update translations for description.mdx. And it literally points out which file got changed, what all languages got affected, like what all languages was, and even the time when they were last updated, that Spanish was updated on this date, Hindi on this date, simply for Korean and simplified Chinese. And it also tags the relevant stewards in these particular languages. Like it will tag like this. So they get notified in real time of like what exactly was changed. And it also has this action checklist, so they can review the recent English file and they can, work accordingly, and they can even assign someone to work on this. And it also has this very nice thing, the description thing. You can basically check the last commit and you can exactly see the lines that were changed. And not only this, it is not only like for the stewards or contributors, it is also for the users. So for the users who are visiting the website, suppose that color was changed, so they will see a banner like this. Suppose I am on the Hindi version, so I will see something like this, which basically translates to that the page that you're seeing, it might be outdated compared to its English version. So either you can, that there are also two inline links which says either you can switch over to the English version to see the latest version, or you can even contribute to the translations. This was about like what I did. Now how it actually worked, a brief about what exactly happened under the hood. So basically, just like other GitHub action which are set up in p5.js website, it is also an action that runs on the node.js script. So basically, there's a script written that compares English folder, which is the source directory, and then content in that can be example, that can be tutorial, that can be text detail, that can be events. So it compares it the files located in the English version with respective languages, and then it uses OctaKit GitHub API to create an issue. One thing to note here is that this folder like comparison only works for examples, text tutorials, these things. It doesn't work for reference yet, because that is a more complicated part. It's like it gets in from data.json, that is a whole complicated thing. Not going to that. So after the issue gets created, it will have the affected file, it will have a summary of what got changed, it will also assign the stewards. So what it did, it basically rather than not automating the whole thing, because we can't depend upon the machine transaction to give the native field to the users, rather than doing that, we reduce the manual tracking effort of what exactly got changed. User can, or someone can just go on to issue, filter according to label, filter according to language, filter according to translation, and they also get notified, because if they are a steward, they will also get notified that they were tagged in some issue. So they can either review it, they can contribute themselves, or they can just close it if that is not relevant to them. So yeah, this is it. Apart from this, there's a lot of, I will encourage people to contribute in this. There's a lot of future scope in this project. We have the banner I showed, we can just improve the UX of the whole banner. We also have to integrate the reference part up, and we will also love to improve the diff comparison logic.
Thank you so much, Divyansh. I hope that you see all of the little emoji reactions that are like coming up, floating up from the bottom. Very awesome to see this, and I hope this really inspires some new contributions to our documentation, especially for those of you who are multilingual. Thank you. All right, our next presenter is Ego, who's developed the P5 Sketch Embed tool for blogs and websites. So this new tool makes it easy for creative coders to share their work online. So Ego, go ahead and take it away.
My name is Ego. I have a degree in political science and I worked in sales as well. So I've always wanted to be in tech, and I came in through the self-taught route, right? And this all came in at the perfect time, and not for the project itself, right? But for the mentorship that it actually brings. So I built a P5 sketch tool embedder. It helps users embed their sketches, and it supports different modes. It simplifies the way sketches are embedded. It supports all different modes, the instant, global, and also the iframe mode. The tool that I use, so I use React.js for dynamic user interface, Code Mirror for the styling, and also Netlify to deploy and host. So for everyone that's worked on the P5 editor, the next best thing after that is for you to say get a shareable link that you can use to share your sketch. Say you want to post it on, you want to put it on your website or feature on blog posts, or you want to say share to your friends and all that. The next best thing is that link to use, and that is what I aim to achieve in this project, to get the link. So what I wanted to do is to generate a direct code link, right, using iframe. I wanted to use the SERdoc attribute. It's an iframe attribute. I had a lot of roadblocks working with that. For example, browser do not allow more than 2 MB. Whatever you're embedding in an iframe, say you're adding JSS, JavaScript, and even assets. Then we had security blockers as well. So we're embedding like an entire HTML into the iframe. So it had a lot of blockers, whitelist, which very interesting was the whitelist actually. So website like WordPress, right? So they have a list of websites that can work, that can embed on their platform. Not everybody can embed. So I got on a call with Keith and my mentor as well, and we went the CodePen route, right? So CodePen has a preview features. What it does is that you can send an entire front-end code into their live code editor. And with that, you can get a shareable link. You can edit the sketch as well. I have already pasted sketch that we're going to be working with. So here we're up. So it's a the UI is very easy to navigate, right? So like I said, we have already pasted sketch that we're using here. So you can preview your sketches and it comes up here, whichever way you want it. Yeah, so you can preview your sketch. It's regardless of the platform that you want to embed. So you go to say you want to embed WordPress, you can read through the recommended way to embed there as well. So you want to work with how to work on CodePen. It's very detailed, very easy. And we recommend using the multi-sketch. So multi-sketch mode, yeah, so it's recommended. So you just click on the mode you want to use, iframe, whichever mode you can copy as well. And just click on open in CodePen. And voila, we're in CodePen already. But to get a unique link, so you need to save your sketch, right? So when you save it or fork it, it gives you a unique link that you can use. So with that link, right at the bottom here, you click on embed. And after you click on embed, it takes you to their embedding environment, whichever method you want to embed. WordPress, HTML, body recommended HTML. Also, HTML here on CodePen is very much recommended. And you click your link, go to see the pen. Just this link alone, you can use it to embed everywhere. So for example, on WordPress, you will have here, already in WordPress, you can view your sketch whichever way you want to view it, on whichever platform. Like I said, on the tool, you have different recommended way, different platform, and the way to view it. So yeah, so going forward, which I'm very much excited about, we voted to the CodePen route because we had blocker using the direct link that will aim for initial. So going forward, sorry, my speaking clear. But going click on, if they click on generate code or generate embed, it gives them, it comes up with a shareable link that they can use, and they'll get a link like this on the platform, like what I have here down here, Firebase. We're using Firebase to host. They get just one single link. When they click on generate, with that link, you can share your embed or your sketch to whichever platform you want to share and to who you want to share with. I am very much thankful to Dora. Dora is more than a mentor to me. Like I said, just sort of experience going into it, but it was a blast for me. And I'm so thankful to Dora for that experience. Kate, I'm also thankful to Kate. And she came on board. Amy and Rachel, so I am very thankful. So of course, it's open source, and we have a lot to do in future, like I mentioned earlier. If you want to check out the sketch, the Notify link is here, and also GitHub as well. I'm looking forward to a lot of contributors. And also, if you have questions, I am very much open via my email. Thank you.
Thank you so much, Egu, and to all the Google Summer of Code contributors for those wonderful presentations. Now, we will hear from our PROS contributors. The Processing Foundation Software Development Grant, or PROS, is a grant and mentorship initiative by the Processing Foundation designed to support the professional growth of early to mid-career software developers. The theme for this second year of the program was building bridges, focused on strengthening the links between the processing and P5.js ecosystems while also aligning them with modern coding best practices. First, we'll hear from Vaivaswat Dubey, a developer and student passionate about technology and music. He is a P5.js steward and is pursuing a bachelor's degree at the Indian Institute of Information Technology, Gwalior. With support from the PROS grant, he built a snapshot testing system for processing. Please welcome to the stage, Vaivaswat.
I'm Vaivaswat, and today I'm excited to share with you a project that addresses a critical challenge in the processing ecosystem. That is the visual regression testing. So let me start with a simple question. How do you know as a contributor to processing that your code changes haven't broken something visually? In traditional software, we write unit tests. But in processing, where the final output is literally what you see on the screen, the art, the visualization, and the interactive experience that you get. How do we ensure that a seemingly innocent code change hasn't changed something big in the library? We want to ensure that contributors' code changes doesn't break users' experience using processing. Now, let's think from the point of view of a new contributor in processing. Consider this. You change a single line of code, maybe you refactor a function or update a library dependency. And suddenly, a circle that was supposed to be at the coordinates of 200 to 200 is now at 202. That has been shifted by 2 pixels. Or a carefully chosen color palette shifts because of a rounding error. These are massive visual regressions, but they may be invisible to traditional unit tests. This is the problem that visual regression testing solves. And over the next few minutes, I'll walk you through the journey of building this system for processing 4, and in the end, we'll see a short demo of how that works. So what exactly is visual regression testing? As I just explained to you, it's a suite of test sketches that creates small, simple images that specifically test a specific functionality. It's an automated system that compares 2 versions of a rendered output, pixel by pixel, to detect visual differences. Here's how it works. When the first test is created, it is run once to create the baseline. This baseline is stored with the repository. Then as you develop something and make changes to the repository, every subsequent run captures a new image and compares that with the baseline image. If the new image deviates from the baseline, the test is failed, and you know something has changed visually. For processing specifically, this is critical because the final image is the delivery. Originally, starting in the project, P5.js already had visual tests, and the motivation was to see if we could leverage the existing test and ecosystem for processing 4. However, processing is a Java and Gradle-based system, and P5.js is a JavaScript-based system that uses Vitest as the testing infrastructure. Now, when we started this project, I had a very pragmatic approach towards the solution. We were supposed to build a shared engine architecture that could work across both processing and P5.js. The idea was elegant. Take an existing battle-tested library, which was called Pixel Match, which is a JavaScript library for image comparison, and extract it into the standalone NPM module. Then we would build platform adapters that would allow both processing and p5.js to use the same underlying comparison engine. But here's where theory met reality and reality won. As we tested this approach and thought about real-world usage, one critical insight emerged. Contributor friction matters more than elegant architecture. Let me explain what I mean by contributor friction. So processing has a diverse community. Artists who code, educators, students, creative technologists. Many of these users aren't professional software engineers with complex development environments. Asking them to install Node.js and NPM just to run visual tests for a Java-based project, that's a huge barrier to entry. So in August, we made a pivotal decision to abandon the shared engine approach entirely and build a self-contained Kotlin solution. Now let me walk you through the final architecture. Yeah. The final architecture was the complete visual regression test runner built entirely in Java, consisting of 3 core components. First was the sketch runner. This component's job is to run up users processing sketch in a controlled and headless environment. Now, headless here means without a visible window. We are running the sketch purely to capture its output and not to display it interactively. Secondly, the visual test runner, which is the orchestrator of this entire program. This is the brain of the system. It manages the complete test workflow. It captures the image, compares it, and reports the result. Now, thirdly, the image comparator. This is where the actual pixel comparison happens. We built a custom native implementation that compares images pixel by pixel. The algorithm calculates color differences using Euclidean distances in a RGBA color space. That's the square root of some of the square differences in red, green, blue, and alpha channels. Now, moving on to the critical technical victories which we had throughout the project. Firstly, teaming the p-applet threading. Processing's p-applet runs in its own thread with its own life cycle, which is of setup, draw, and redraw. When you are running a sketch interactively, this is perfect. But for automated testing, it's a nightmare. I needed to ensure that the test thread doesn't proceed until the sketch has fully rendered its image. I implemented a bespoke system using p-applet.runSketch, which is a function to run sketch in the p-applet threading. Secondly, we had a robust differentiating logic. Raw pixel match comparison is very easy. Just check if every pixel is same as the another pixel. But that's too naive. Real-world rendering produces minor noises, anti-aliasing artifacts, and subtle line shifts, which often shifts by some pixels. Might be a single pixel or multiple pixels. Often the differences come in slight color variations from floating point rounding. The image comparator, which we have currently, is tuned for practical use. It intelligently filters out false positive caused by these minor rendering differences. And when a test does fail, when there is a genuine visual regression, the system automatically generates a clear differentiating image that highlights exactly what changed. This makes debugging trivial. So what we have built, a zero dependency native Java visual regression testing framework that integrates seamlessly into processing's existing ecosystem. Contributors can write visual tests as easily as they can write real sketches. No external tools, no complex setup, and just pure processing. Now I'll move ahead to the demo part of the presentation. So here we have the IntelliJ IDE, where I have Fog map processing repository. And as you can see, I will just now run the test. So currently we have a lot of tests written already, which are of shapes and some fonts that I wrote originally. So as you can see, windows are popping up of particular sketches that are being drawn. And these sketches have been ported from p5.js, where they already have visual tests. So as this is done, you get a report of whether the test is being passed or not. So yeah, as you can see, we have the report of the tests which are being passed. And as currently we have very few tests, so we don't have any failing tests, which I have tested that before, but I can't show you now as the build will fail. So yeah, but you can try that out in when the PRs will be merged. So yeah, that is from my side. Thank you.
Thank you so much, Vaivaswat. If you have questions in the audience, please ask them in the Q&A panel. We already have one, so Vaivaswat, feel free to go there and answer that one. Our next presenter is Claire Peng, a Chinese Canadian developer and designer based in London, formerly a menswear designer. Her designs have been worn by artists like Chance the Rapper and Machine Gun Kelly. Now, working as a software engineer, she specializes in UX UI design, web accessibility, and advocates for making tech approachable and inclusive to those from non-traditional backgrounds. With support from the PROS grant, Claire has been leading the TypeScript migration for the P5.js editor. Give a warm welcome to Claire.
My name is Claire. I'm going to be talking about the P5 web editor migration today. So for those just joining or new to processing, P5 is a free JavaScript library for creative coding, and you can use it no download required with the web editor here, which is the project that we're going to be working on. A bit of personal background. As mentioned, I used to be a menswear designer, and I learned to code starting 2023 to do a career switch. Now I'm a full stack developer at Spotify. The reason I got into this project was that I actually got into JavaScript through P5.js. So this is a project that's super close to my heart. So we're doing this TypeScript migration, but what does that all mean? What's the difference between JavaScript and TypeScript? TypeScript is like JavaScript, but with extra stuff on top. So in addition to your usual code, you also have types. So that's string, number, Boolean, array, object. These are examples of each of those types. And you can think of types as being similar to like parts of speech in English grammar. So noun, verb, adjective, preposition, etc. So just to illustrate this, does anyone remember the game Mad Libs? I like to think of it like when you're coding, you're often editing stuff that other people have written. So it's a little bit like Mad Libs. So you have all these blank spaces to fill in. In JavaScript, it would be like Mad Libs with 0 hints. So you can definitely still fill in stuff, infer from context clues most of the time, but I think it can be quite hard to figure out what a past writer wanted you to do. And on this video on the right, we have this greeter function. You're supposed to plug in something called name. So the first usage of this instance is like correct. You're plugging in Kevin. That's a name. What if you plug in nothing? What if you plug in 1? What if you plug in null? And you run the code. In JavaScript, this all runs, but if stuff is using this downstream, it could totally break your code. So you're not supposed to be able to do this, right? But we don't have hints on the fact that you can't do this. In TypeScript, it would be the normal version of Mad Libs that we all know. Here's the TypeScript version of this greeter function. So it says name has to be a string. And so when you use it wrong, you'll see that you get these little red squiggles. These are type checks. It's like spell check or Grammarly. And then if you hover over, it'll say, hey, you can't do this because you put in null. It's supposed to be a string. So you have like visual guardrails. I think it's super useful, especially as like a person from a non-technical background, to have these visual guardrails because I learn visually. I don't have to read loads of documentation to understand what something is supposed to do or understand loads of theory. So here's some context for the web editor project or the code base. Some things to highlight for the migration are that this repository is huge and also started in 2016, so a little bit of legacy code. There's 100,000 lines of code, so it's not possible to migrate the whole project within this 200-hour time limit. And as such, because we're probably going to migrate things file by file, we'll have to support both TypeScript and JavaScript. And also the test coverage isn't super high, so we have to be careful of accidentally breaking things. And it's also like a quite highly requested issue. So nice that we're doing that. So given these challenges, I decided the ultimate goal wasn't to migrate the entire repo, but actually to set it up so that beginning contributors can pick this up as a good first issue. So migrating a piece of code as a good first issue. What this means is like eliminating all the friction from having to configure TypeScript. Here's all the tech that we have to configure to allow both TypeScript and JavaScript. Having example code for each kind of file that you might encounter on the code base. Here's types of files that you might encounter on the server, on the client, and ideally have examples of writing tests for each kind of file as well. And lastly, setting up tooling and automated checks. So that spell check that I was talking about, the type check, having that run manually or automatically when a user is trying to save and upload things or add changes to the code base. So here is a project timeline of stuff that was done month by month. Just due to time, I won't go into this super in detail, but I linked the appendix so you can pop in, and there's loads of technical documentation for anyone who's interested in that kind of stuff. So 20 plus PRs and 4 months later, what was changed? What happened? We're gonna pop to a demo. So here is the before state of the web editor. Here's what it looks like before. And here's what it looks like after. Ta-da! Huge difference, right? Just kidding. If everything was done correctly as a user, you should see absolutely no difference. If you do, something's gone terribly wrong. I had a really hard time thinking about how to show this migration project because migration is very invisible. But I thought of an analogy again. I think it's a little bit like cable management. So for the user, you come onto the site, you should see the exact same thing before and after. But as a developer, you're working into the code. Hopefully the after is going to be a lot neater and easier for you to work into. So in summary, we have all of the config and checks set up. We have 20% coverage for TypeScript. Canva is not participating with me today, but I will show you the demo video on YouTube. So we've migrated a bunch of files in both the server and client, really quickly looking at all the files that are migrated. Everything that's blue is TypeScript. Everything that's yellow is still JavaScript, so still some stuff to migrate for sure. And to demo the automated checks, I'm going to purposely do something that is against TypeScript and put in something that's not expected. So you can see here, you can hover and see that, hey, it's going to give you hints on how to use this component correctly. I'm going to try to commit, and the automated checks that come before you commit are going to happen, and it blocks you from updating, pushing that code. I also made a tutorial for anyone who's sort of new to JavaScript and TypeScript. I go through the general steps of migrating a piece of code. This is also a YouTube link within the appendix. And I'm not a content creator, so I'm sorry. This is made on iMovie. It looks really ugly. But for anybody who's interested, I would also be interested in hosting a migration workshop in the coming weeks. So if you're interested, please do say so in the chat. Otherwise, all the config has been figured out for contributors to start tackling migration. So yeah, go for it. I have some next steps outlined in the appendix as well, but I just wanted to highlight this one, creating a Swagger/Open API website to document all the endpoints. So I made this proof of concept using the user types that were defined as part of my migration work. As you can see, it's just a central location to define all your API endpoints and make them super clear. I think if you configure it correctly, you can try it out as well. And yeah, just see all the different types on the code base. And thank you so much. That was all. I'll reshare the appendix and PDF version of these slides in the chat for anyone who's interested in a deeper dive of this project. Thank you so much.
Thank you, Claire. Best analogies. Up next is Stephan Max. Stephan is a freelance software developer based in Cologne, Germany. He works mainly with NGOs, nonprofits, and community organizations, creating and maintaining tech for people who might not otherwise have access to it. His expertise ranges from web platforms and data analysis tooling to playful creative experiences. And lately, he's been experimenting with making art using his trusty pen plotter. With support from the PROS grant, Stephan implemented desktop support for P5.js via a new processing mode. That's a project I'm very excited about. Stephan, the floor is yours.
I'm Stephan, and I'm very excited to share with you all what made the grant program during the last 4 months so special. I've been particularly happy about the chance to build a bridge between these two beloved and very prestigious tools, P5.js and processing, because building bridges has become somewhat of an occupational hazard for me, usually between the realm of tech and the knowledge domain of my clients. Because as you can maybe imagine, my work ranges quite a bit from automatically creating configurations for 18th century Chinese puzzle game Tangram for a procedural generation hackathon to, of course, also way more serious endeavors like consultation around anonymous online counseling for victims of racist violence and the open source intelligence platform Syrian Archive. And now, given that, some might consider this a bit of a wild mix, but if you're looking for like-minded spirits, I don't think you have to look that far, because you will probably stumble upon the Processing Foundation pretty quickly. That's because that's why this is my pillar number 1 out of 4 of what makes this grant program very unique. I feel a lot of my core beliefs align very well with the work of the foundation, in that tech should be free and open source, facilitating both engineers and artists to find insights and joy in each other's craft has a very high potential to become like much bigger sum than those parts combined. And buzzing creativity and whimsical playfulness can definitely shape tools, tech tools in particular, that better your sphere of influence. Now, that is not coming out of nowhere. Processing has been my companion for a while now. I don't know if any of you recognize the book on this slide, but the English title is Generative Design, Visualize, Program, and Create with Processing. And it is from frickin' 2009. I got the original German version here, kind of as my little lucky charm. And I bought this copy in 2009. So that means I've been working with processing for over 15 years. At university, teaching students, on a lazy Sunday, trying out a new creative coding idea, and lately also for my pen plotting art. And with this grant and the opportunity to contribute, I feel really I've come full circle, and that is a wonderful feeling. Sentimentality aside, I had to learn a couple of things before I could properly contribute in any meaningful way. The PROS grant marked my return to the Java ecosystem and to building desktop software after having built for the web for years and years. I learned my way around the IntelliJ IDEA editor and Processing's new Wish build system that is based on Gradle. I learned, and I gotta admit, fell in love with the Kotlin programming language. I can't wait to use that skill to get into Android app development. And I also used Compose for the user interface. This level of challenge was really perfect. It managed to get me out of my comfort zone, and at the same time, it was not too overwhelming. So I learned a ton, not too overwhelming, although I have to thank also those people on the next slide. These 3 people massively contributed to the latter. So pillar 4, the support from left to right, is Steph, my mentor, who has been excellent and acted as a great source of all kinds of advice, workarounds, and guidance. Then there's Raphael, who supported me with his seemingly endless patience. I don't know how you do it, and the perfect amount of project management. And both Steph and Raphael almost cured me of something that I tend to do, which I call premature rabbit holing, and reminded me that I'm working on a tool that, at the end of the day, ultimately has to be steered by the people who are using it out there in the wild. And Amy, who helped me remember that it is okay, that it is more than okay to sprinkle some creative magic on everything, even on a deliverable as rigid as a piece of software. I love our chats. Thank you, everyone. And now I'd love to show you a little demo of the new P5.js mode for processing. So a mode is really a plugin of sorts, and it will be available via the official contribution manager. And then you can choose P5.js from the mode dropdown up there in the top right. It extends the processing development environment with the tools and the glue code that enable it to build for you to build, debug, and run P5.js sketches that are written in JavaScript, as you can see there in the editor. And then once the code is done, this is a sketch of mine preloaded. We can run it with syntax highlighting, the usual editor experience. If we hadn't introduced any bugs, that is, but fear not. As you can see down there in the status line, errors are getting reported back to you into the processing tool. And once all the bugs are taken care of, the sketch actually runs in an embedded Chromium browser window powered by the Electron framework. That way we get an experience that is very similar to developing P5.js sketches in a browser. And again, the status line and the console down there at the bottom of the editor window give you a little glimpse of what is going on behind the scenes, a little bit. But Electron offers us way more than just an embedded browser. It packs the full punch of the Node JavaScript runtime, which means that we can search for and install any third-party Node package that we desire. That piece of UI is, as you probably have noticed, extremely work in progress and subject to change, but doesn't matter because you can simply and directly change the package.json file. And as you can see there in the file browser, a P5.js sketch, even if it's inside processing, is still just an ordinary JavaScript project. There's nothing hidden, no vendor lock-in is imposed on us. And we could, just add or remove any dependencies there. Another huge benefit of turning to Electron is the possibility to export our sketch as a standalone application for your platform. So going to export application, inside processing kicks off a build process that is fueled by Electron Builder and creates a standalone executable that bundles your sketch and everything, all the files that it needs to run in a nice package that even if you're not in the processing development environment anymore, you can run. And with that, you have a neatly bundled pack that you can run offline, standalone, put in a thumb drive, pass around. And that is, one of the beauties of using Electron. And that is the end of the demo and also my presentation. Thank you everyone so much for dialing in and your attention. And
Thank you so much, Stephan. Amazing work, everyone. Great. Okay, we're going to move into a panel discussion with the 6 presenters that you just saw. Their mentors have prepared questions for them to answer. So we're also very happy to answer any questions from the audience by using that Q&A feature at the bottom of the navigation bar. Please populate that with questions and our presenters will be going in and responding to those. But moving on to this panel, at the Processing Foundation, mentorship is really at the heart of how we grow and sustain our community. And we believe that it really just sets us apart as an organization. Our mentors not only guide projects, but also build relationships that nurture the sense of belonging and confidence in the technical skills and soft skills among their mentees. So let's get started with this Q&A by inviting Connie to the panel to ask the first question to Claire.
Hey everyone, I'm Connie, Claire's mentor for the migration project. First of all, thank you and huge congratulations on the amazing work these past months, Claire. The speed and thoroughness at which you worked was so amazing and incredible. I feel like you really set the standard for collaboration and it was such a delight to work with you. So my question for you is, what surprised you most about the TypeScript migration process and what did you learn through it?
I think the hardest part about it, maybe it wasn't unexpected, but I guess the level to how difficult it would be to add in types retroactively was surprising. Because it's pretty old code base. It's like almost 10 years old. And there are a lot of components where as you discover more of the code, you're like, oh, I didn't expect that actually this piece is connected to that piece because maybe there have been renames and like structure misalignments. So I made up this principle, which is in the appendix of like principle of best effort and increasing precision with doing the TypeScript migration. So at first, when you might not have as much context for the repo, maybe you'll define something as a string, like a broader type. And then as you learn more and more about all the parts that interact with that piece, maybe you want to narrow in and say like, oh, it's actually an enum. It's like a bunch of different states. So yeah, I think maybe that was surprising on like a good workflow to proceed with.
So this question is for Divyansh, who is my mentee for GSOC, and it's been great to work with you on this project. You brought so much thoughtfulness to it, and also your past experience with translation on P5. And I wanted to ask you to share a bit about your future hopes for this tool or as a P5JS translation steward.
Yeah, thanks a lot, Kit, especially for mentoring me this summer and handling all the last minute PR delays and everything. So yeah, first of all, because this project was something which I initially didn't decide to participate, particularly in GSOC this year because of some other commitments. But since last year was a transition project, and when I just saw that this project was in the pipeline, especially initially the scope was only for reference, but when I saw this project, I was like, this is something which I want to do, which I previously also did, and this is something I want to do. So I initially just signed up as long as the future scope is discussed. Obviously, there's this the whole reference pipeline which is yet pending. Then there is the to improve the logic for the def comparison. And as we discussed last time, so for everyone to know, we are also exploring possibilities for not only trigger this particular GitHub action only on the English language, but also on the other languages too. So this is also something which I'm looking forward to. And yeah, as part of the contributions are considered, I think translation contribution are the perfect one to start with if you are new to p5.js and you are just learning it, particularly if you're learning in your native language and you just saw something, okay, this is something which is missing, or this is something which I type I just want to finish. That can be a very good your first open source contribution to a really big project which doesn't even require that much of technical expertise. So yeah, that is what I expect. I expect more of PRs. I expect more of organized translation work from the contributors. And who knows, maybe we can see more official versions in other languages too in future for P5.
I have a question for Stephan, and thank you for your work on the P5JS mode during pros. Your mentor, Steph Tervelde, would like to ask, during your work on the P5JS mode, was there any clever trick or workaround that you discovered that really excited you?
Well, first of all, I'll give Steph my best and thank him that he assumes that I did something clever. I think I would like to mention the tool PMPM. So we had this challenge with this P5JS mode, right? That was, we would like to have a mode that comes with all batteries included. So like the normal processing environment. So people shouldn't have to install any other tools or software. And we also didn't want to assume the existence of something like the Node.js runtime on any user's machine. So for package management, we already looked at different tools and ended up with PMPM because PMPM is doing something very clever in that it reuses dependencies. So if you would have 12 sketches, you wouldn't have to install Electron, for example, 12 times, but only once, and all the sketches use the same dependency. So that was already pretty amazing. But then I realized that PMPM also serves as a node version manager. So if you guys know the tool NVM, it's doing something similar in that you can install different versions of Node and then set the active version that you're using. And yeah, that then blew my mind completely, because then that solved most of the issues that we had for third-party dependencies around the JavaScript ecosystem. So PMPM doubling as a package manager and a node version manager. And yeah, that level of detail and thoughtfulness in a tool just excites me. And it also always pays off to read the docs and look what a tool can do.
Great. Thank you, Stephan. Thank you, everyone, for your answers to those questions. We've run out of time because we're having so much fun to ask Ego's and Vaivaswat's questions. So what we're going to do is we'll put those into the Q&A and then they can respond to it written. So that we can move on to the next segment. And thanks so much again to all of the technical presentations. You all did amazing. We're going to move into the second portion of the event where we feature our 2025 Processing Foundation Fellowship. I'd like to offer a very warm welcome. So if everyone could make some silent noise, emoji reactions, comments, smiles, body movement, whatever, for our co-executive director, Shin. Please come onto the stage. Yeah, so much love. All right, take it away, Shin.
Thank you so much, Amy. I'm so excited to be with everybody here. Thank you so much for joining this annual celebration of the Processing Foundation. I am here to introduce the next program, the second portion of the event. Since 2013, the Processing Foundation Fellowships has been an incubator for early career artists, engineers, and educators to imagine a just and equitable relationship with technology. But the technological landscape we had 12 years ago is really different from the one we need to be critical of today. This year's fellowship projects are asking, in an age where data shapes every story we tell and hear, how are we collecting the data of our communities? Who owns it? And crucially, who gets to aggregate these data and tell stories with it? These are the questions that are driving this year's work. And with that, I would like to introduce our first fellow presenter, Daniel Corbani, based in Brazil and collaborating with local theater communities. He is presenting the Luna Video Mapping Library, an open source processing library that brings projection mapping and interactive visuals to the performing arts.
You know, those people that say technology is just a tool that cannot make art. And I'm here to agree with them. I see the same for dancers' flexibility and actors' voice. They are all tools. Art doesn't live in the tools. It lives in the experience we create with some strangers for the time of the performance. I'm Daniel Corbani. I'm a creative coder dedicated to performing arts, the creator of Luna Video Mapping Library for processing. But before we see the library, let's appreciate a performance created especially for today. That was Paula Igar, a dancer, choreographer, and art therapist. A friend of mine, I invited her to test Luna because of these studies she does with dance and drawing. She uses charcoal to dance and draw some mandalas with her entire body. To talk about why creating Luna, I could give you an enormous list, but the main reason was to use the full potential of processing to create generative content and maybe create those I visualize interactive content and use them on stage. I try to make Luna close enough, or at least aiming a commercial software as good as commercial software, but of course it's always good not to pay for a software license. And I've seen already the impact that the library has in the community and local artists who cannot afford it, cannot afford the commercial software. Talking about the scene, the performance composition, the inspiration was her mandalas, her work with mandalas and the features of Luna. Scene one is this pre-recorded video of her dancing and doing the mandala. The idea is to create the illusion that the real Paola entered, but it's a video now seen to have a merge of the physical Paola, the digital one. And scene three brings this full merge of the body, creating the image in real time. So it's her presence creating this fluid, this smoke, and it's her movement that is disturbing the fluid. To work with Luna, first steps are this example you'll find in the library folder. You just need to run it. The main class is the project. You name it as you wish. You include all the video and picture you want to use and run. You will see the user interface. Optionally, you can create some content, some generative content like I did. I won't get into details of technical details. Let's call it a bridge. So if you do the way it is, that there's an example about that, Luna will see the content as it was a video. So the smoke generator was done using the PixelFlow library by Thomas Dewald. I hope I'm pronouncing that correctly. There is a method called background subtraction. You take a picture of the scene, the background. Now, every frame that comes in from the camera feed, we perform a subtraction and a threshold, and now you have a mask. That is the source for the fluid simulation. Both are in the PixelFlow, and that's what you see. This is the user interface. I use Control P5 for the buttons by Andreas Schlegel. Again, I hope I'm pronouncing that correctly. I know everything is small. I need to fix it. But for today, I'll give you some zoomings from at the left panel. You see all the media you put in the data folder. On the right, you see all the generative content you created. And down, you see the buttons to create scenes. And that's all we need for now. This is a video showing me how I created this scene, this performance. I created scenes here. Now I include a white picture, just that a thumbnail shows up, click on mapping, and after that you can move all the four corners and map it onto the wall or any surface you want. Now, cool thing, you can simply copy this configuration and paste it onto the next scene. So you don't need to remap everything. Now, the next scene, I include the video, the pre-recorded video, and just paste the configuration. Voila, you have your mapping. But in this scene, I don't want to project the entire video. I want to remove the excess out of the wall. So I start mapping again, and in-out button goes to the input mode. And I'm kind of cropping the source to be mapped onto the wall, and leaving the excess out of the projection mapping, and as easy as you did with the output. Once you go back to the output, you have it. That's it. You can use the same strategy for the generative content. Finally, some learning reflections. I want to share. AI is great, but not a project manager. Large language models can speed up writing small functions like converting a vector from one space to the other space, or creating a flow or some functions, I don't know. But every time I try to use AI as a project manager, it led me the wrong way. I need much work to redo what's wrong. And user interface should reveal, not conceal, meaning the idea of user interface is to ease things, to facilitate, but you need to debug sometimes. So you should have access to the functions and methods in the sketch and the code. Finally, I'll invite you to check luna.art.pr. Everything is in Portuguese right now. Please give me a couple of weeks. I'll create some content for that and share with you. Maybe have a space for sharing projects and ways of using Luna. That's it. Thank you, everyone.
Next up is Leonardo Aranda, who will share with us a little bit about the history of Mexico City and its bodies of water and how to interrogate them using digital cartography.
Where Has the Lake Gone consists of an artistic research that tells the story of Mexico City from the perspective of its bodies of water, through experimental cartography and the use of DIY sensors for the production of urban data. But first, I want to tell you a bit about myself. My name is Leonardo Aranda. I'm a media artist based in Mexico City, and my work focuses on the creation of urban tactical devices, participatory platforms, and counter cartographies in the context of art. Where Has the Lake Gone was born in response to the current crisis facing Mexico City, which can be described as a cycle of droughts and floods. Originally built on a lake, Mexico City has now lost most of its bodies of water, hidden beneath asphalt and drained to make way to the urban sprawl. The project motivation grows from what Rob Nixon calls slow violence. That is, a form of violence which occurs gradually and is not necessarily visible. It's incremental and is a dynamic across time, in contrast with a conception of general violence as an event or action that is immediate and spectacular. What makes the recent cycle of climate impacts in Mexico City seem less like a social emergency is the water control project has been developing for centuries. Before the colony, the city water system was based on the idea of coexistence with water. The project now is based on the argument that the relationship with water in the Spanish conquest reflects the colonial tendency to try to control nature, which is reflected in the different efforts to plagues that surrounded the ancient city of Tenochtitlan over a period of 500 years. Mexico City has undergone a radical transformation over this period, from a city surrounded by lakes and crisscrossed by rivers and canals, to a city where water is scarce, Rivers and canals have disappeared, and cars have taken their place. You can see in these images some of the infrastructure that are part of current Mexico City water system. Today, all the rivers in Mexico City are piped underground, and where there used to be boats crossing the city from south to north, now we only see cars trying to survive the city traffic. Still a work in progress, the project has been guided by the following exploration during the fellowship. First, how to make visible systems that by their very nature and magnitude tend towards opacity. Second, how to make water infrastructure legible. And third, how to present the complexity of these systems and their evolution over time. In this sense, the project attempts to answer the question that give it its title through a process of research, both real and speculative. In this sense, the first period of the project focused on the research with various historical archives, including documents, maps, and pictures. And I will show you a bit of the results of that research. From the archival work, the project produced a large amount of geographic information. A central objective of the project has been to create a digital cartography based on this information. This map, the map that we are looking at, explores new forms of cartographic representation, which seek to break the common notions of visualizing georeference data. What we are seeing is a 3D environment created entirely in processing, where georeference information is represented through different depth values. The intention was to represent the city as a stack of infrastructure layers that reflects the historical sedimentation of. Another important objective of the project has been to reveal and make legible the hidden infrastructure that is part of the history of the system. This infrastructure consists of villages dating back to the pre-Hispanic and colonial eras, in plain sight in the urban landscape of today's modern city. During the project, I scanned several of these infrastructures with the aim of revealing their importance in the history of urban transformation. What we are seeing is the result of those scans visualized through processing. The image that you are seeing are different monuments, different parts, infrastructures that still remain in the city, but they are usually not seen by the people that pass by through them. So for example, this is a bridge, and the next one is, this one is the oldest fountain that I think from the continent, and people pass by it daily, but usually no one knows exactly what it is or what is its importance. And this last one is a tower that is part of the aqueduct of the current water system in Mexico City. From a more speculative perspective, the project attempts to map those spaces that were previously rivers or canals, searching for what remains of the bodies of water. For that purpose, I built a DIY GPR. GPR is a ground penetration radar sensor, based on the prototype by Romanian engineer Mirel Pon. The images that we're seeing are some images of that development. And now a small video about functionality of this. A GPR is, as I told you, it's a ground penetration radar that basically works like an ultrasound that sends radio signals into the surface and creates an image in response to the return of that signal. What we're seeing is the assembly of a sensor on a vehicle, which is intended to travel the streets of Mexico City. The vehicle is inspired by the traditional tamales daily, a way of camouflage the project into the everyday landscape. These images are of the underground, like that is a kind of like a graphic that shows you that the device shows you when it is scanning the underground. The intention of this device is to explore the city, carrying out an embodied investigation which generates an image of the underground that attempts to answer the question, where has the lake gone? That is me going through the streets of Mexico City. The result of this mapping is a data visualization that allows us to speculate about the existence of water hidden beneath the asphalt in an attempt to restore our coexistence with water. And that's the project. So thank you very much for your time, and thanks for Processing Foundation and its incredible team for the support that made all this project possible. If you're interested in learning more about the technical aspects of this project, please join me in my breakout room after the end of the presentations. Thank you.
Thank you so much, Leonardo. All right, we'll move on to the next presenter. This next group is elekhlekha, the duo that is Fame and Kang. They will demonstrate how their browser-based digital Gong ensemble creates shared agency through Southeast Asian sound cultures, resisting disappearance and dominance erasure while evolving musical traditions through collective archiving. Kang and Fame, please take it away.
Hi, my name is Nisha Tong. You can call me Fame. I'm an interdisciplinary artist, designer, and coder.
My name is Keng Chakat. You can call me Keng for short. I'm a sound artist and improviser, and together we are elekhlekha.
Elekhlekha is a Thai word that means chaos and non-direction, to break free our practice from being labeled through the Western lens.
We view our practice as an ever-evolving oral history that function as a way to resist and unlearn narrative that dominate in the system and the media that we grew up with. Network Gong Ensemble Archive is a communal sonic experience site and an experimental interactive auditory archive of Southeast Asia sound cultures, rooted in collaborative agency sharing practices, drawing from the musical ritual of Southeast Asian communal gathering Gong Ensemble.
The archive serves as an experimental repository for sound culture data, allowing us to explore ways to gather, digitize, compile, and capture nuanced and embodied sound that reflect Southeast Asian tradition, where sound cultures are primarily passed down orally, and intonation diversity is common and valued. These are key questions we are asked while working on this project.
How can we collectively understand Southeast Asian heritage through data that echoes with emotional resonance and embodied knowledge? How can we resurrect stories of oppressed communities held within shared practices and create futures where we exercise shared agency through digital collaboration?
How can we create an archive site for South culture data that focuses on community, collective authorship, unofficial personal finding, and story of those who are engaged with the work in Southeast Asia South culture?
So it's an archive that is not just a flat number, but we echo the lineage of sound cultures, story from community that go beyond a raw data.
Often these South cultures differ not between ethnic groups, but rather from one village to another. We view this data as a living entity that can grow, change, and evolve. We hope that this information serves as an invitation for many others to explore Southeast Asian South cultures and as a foundation for us to collaboratively become steward of this knowledge for the future.
We navigate this delicate terrain with reverence, seeking innovative pathways that reconnect with ancestral knowledge and resound the voices of the oppressed while embracing new possibility in this sanctuary. These sounds sonic can breathe, connect, and evolve.
The website unfolds into the two interconnected core functions. The first part is a community-based archive as a site to gather our memories, bundle of sounds, and community memories.
And part two, a network sound making website that based on frequency from the archive. It is a collective sonic exploration in which sound can evolve. However, it still remains centered on the core idea of the Gong Ensemble. During this fellowship, we have been actively expanding our community-based archive with diverse background and geolocation.
This expansion has been a collaborative effort with an outskirt, currently based in Brooklyn, originally from the Philippines. High author are Leonardo, who currently based in Cambodia, originally from Myanmar. And lastly, Salawat Reung Amporn or Khu Am, currently based in New Jersey, originally from Thailand, all playing a crucial role, demonstrating the power of community engagement in cultural resistance.
They all have been invited to share their stories, recording Gong sound cultures that are meaningful to them or their lineage, and reimagine their sound tradition by working collaboratively with us to create an audio-visual P5 sketch to represent their sound on the web archive.
An outskirt contribute Benson Hertz Kulintang sound culture that honor tradition from the fragment past. Bensonhurst is a neighborhood in Brooklyn, New York, where they live right now, and they consider themselves a village of two that carry this tradition and sound culture in their own terms.
Next one is High Outer, who contribute from Irrawaddy to Mekong sound migration, a Khmer Gong sound culture story of survival, and High Outer story of migration fleeing war-torn Myanmar. In their own words, tradition persists not when life is easy, but when it becomes essential. And here's their sketches and sounds.
Salawat Leung Amporn or Khu Am contribute Khong Wong Yai, South cultures. This particular set of the instrument has to be cut into 3 pieces to travel from Thailand to the US. The instrument itself has the trace of migration that is audible in buzz, muted, and rattle.
And here's the sound of the 2 weeks ago, we presented the project as a part of Node 1, organized by Processing Foundation, Artifice UAAD with support from NYU Tandon. The participatory performance and exhibition are the latest iteration of Network Gong Ensemble Archive, where we rehearse agency sharing practices both digitally, online, and physically in real life, while re-echoing the story of practitioners in the communities.
For the installation to reflect the nature of oral history, the interview and story were printed in a long scroll. The interactive website was on one side, and the contributor sketches that you see earlier were on the other side, allowing viewers to listen to them collectively.
And here's some excerpt from the event.
We will demo the current version of the website and host gathering during the interactive section following the fellowship presentation. Please stop by and play sound. Enjoy the ensemble.
We also would like to take this time to acknowledge Jim Kanpapon, a Thai creative coder and collaborative developer on this project.
We are grateful to our contributor, High Outer, Lin Dahachu, and Outskirt, Kuam or Sarawat Ranglamphon for their generosity and sharing their knowledge, sound, and stories.
We are grateful to our mentor, Joanne and May from Data Garden, and also Tommy Martinez. Shout out to Artifice and UAAD for organizing Node 1 for us to showcase this project.
And also special thanks to Munas to help us print and everything for the installation. Last but not least, we are eternally grateful for the Processing Foundation, Shin, Roxana, Amy, Moon, Charles, Kit, Raphael, and Pat, and also Processing Foundation board and staff for believing in us and support this project. We hope to continue work on this project and growing this archive. So please reach out if you resonate with this project.
Thank you so much and take care.
That was fantastic. Thank you so much. Kang and Fame mentioned that there are breakout rooms at the end of the event, and everybody can self-select into whichever presenter's breakout room that you would like to go into. I believe Kang and Fame will be doing a demo and also participatory little moment where you can also create your own gongs and participate in a gong ensemble. All right, thanks so much. We're going to move to our next presentation, which is a Lagos-based project called The Future Protest. It's a collaboration between writer Maryam and software engineer Jubril. Please take it away.
As Amy mentioned, I'm Maryam, and I'm a writer and researcher based in Lagos.
Hi, I'm Jubril, a software engineer and creative coder based in London. And today we're sharing The Future Protest, which we began developing earlier this year. We're excited to share our work in progress with you.
You say by 2050, Lagos will be full of flood.
You sabi say Lagos will drown for flooding by 2050. It's a poor Atlantic that will drown. Those rich people that are enslaving us, yes, that are turning our lagoon, our tourist areas to houses, they are the ones that, in fact, they will sink with the building. That's what will happen. we acquired
Yes,
for it?
because that's natural. I know that they say the whole of VI usually is water. Was water.
Before there was a time we were still young. We still see the water. We standing on the road, we see the water. Water is going far. They are
I saw with my own eyes. I saw that ocean, I saw that lagoon, that beach where people used to come from far and wide to come and just see nature and admire nature. You understand? Now the government and those that feel they have money, they feel they can live on top of it. They feel they want to live by riverside. They want to do ocean view. Yes. And then they're even depriving us the privilege of even going to see what they have done there. Those are the people that will sink in 2050. If there's anything like that.
This is Lagos. The lagoon which surrounds the city is both abundant and precarious. Before Lagos was colonized by the British, the area was lush with wetlands and mangrove forests that thrive in salty or brackish water and support a diverse ecosystem of plants and animals. Mangroves provide a natural habitat for many aquatic organisms and shield inland habitats and communities from tropical storms. But during their imperial rule, the British enacted a deeply racist ethos that defined the colonial relationship with the body of water. And in their bid to cement control of the region and mitigate malaria, they began a huge campaign of land reclamation. Fast forward to the present day, the government has cleared all but a few of the communities which have called the waterways home, and the mangrove trees which surrounded the lagoon have essentially been erased. Additionally, the water receives enormous amounts of largely untreated industrial and other wastes. For example, plastic products, used tires and car parts are some of the waste items that end up in the water through inappropriate disposal methods. But yet and still, the water surrounds the city.
Using the generative capacity of protest as a glitch, which can create an opening, the future protest is a speculative archive which invites a wider public to contemplate the Lagos Lagoon's sonic histories. On a digital platform which streams a video feed of the present-day lagoon, we ask participants to record a description of a protest they would like to hold in future. Drawing on Denise Ferreira da Silva's concept of poetics, not to better the world as it is, but to imagine its end and reconstitution, we've created a poetic algorithm which derives energy values from silence or pauses and gaps within the speaker's recording. These speculative protests create algorithmic mangrove trees that absorb sound, memory, and silence from the lagoon.
These speculative mangroves are composed of plastic bottles and other trash items that appear on the water due to our interest in the relationship between archive and waste, as both rely on a process of separation to parse the valuable from the worthless. These speculative trees ask, what does it look like to acknowledge and work with the waste rather than to erase or forget it? And if we think about protests as a sort of dream space and how they often enact other worlds or modes of being, when the simple act of saying no is threatening to the world as we know it, this creates a sort of pathway for us in thinking about how protest sonics might provide a sort of alternative route of mapping, imaginating, and navigating not just the water, but the world as we know it. Today, we're sharing the prototype of our interactive website, and we'd like to invite the audience to speculate with us, and in particular, imagine a future protest, which takes place today, October 29th, year to be decided. Using the framework of an exquisite corpse, which is a collaborative website or collaborative writing exercise, we're inviting you to imagine and compose responses to the following prompts. We've shared a link where you can input your responses in the chat. So the prompts are, what are you bringing to the protest? Who are you going to the protest with? And when do you know the protest is over? We invite you to respond to whichever prompt you feel able to respond to. We're going to take just about 1.5 minutes for this, and then I will read and demo our collective narrative so we can see how our voices generate the tree on the interactive website. So again, feel free to respond if you're able to, and if not, you can just look at our website while we wait. We are going to begin our demo, but we will continue this session during the next Q&A after this. So if you can go ahead. I will begin. It's October 29th, and I'm taking musical instruments, love, sandwiches, cookies, my body and my heart, snacks in a water bottle, the end of war and violence, my kid, my husband, my hope. I'm going to the protests with myself, my friends around the world, those without the means to defend themselves, my ancestors, comrades, the next generation, disabled people, the community. I know the protest is over when the crowd is not loud anymore, when my body no longer hurts, when change is here, when I'm done, when the seeds bloom and we are free from pain, when there is a revolution. We can stop the recording now.
This animation is one part of a wider project which uses Lagos waterways as a site for speculative research, sustainability, and radical collective publishing practices.
In 2026, we will launch the Library on the Lagoon, which is an immersive installation that creates a collaborative research outpost on the water, inviting passengers to board and sonically record their sentiments, thoughts, and ruminations on protests in the future. Passenger responses will be transcribed onto a device, which is basically a typewriter that powers a trash collection wheel in the water. The typewriter powers the wheel through the energy generated by typing, and this is a working prototype still in process. The exercise ultimately contemplates words as energy and archiving as technology. Through the future protest, water is a site for collective research where archival documentation and words can both touch the water and do in the water. At the foundation of this exercise are publishing acts, where publishing is a collaborative process and a speculative exercise to discover alternative futures for writing, research, and storytelling. Thank you so much to the Processing Foundation and to our incredible mentors. We are really, really excited and just the beginning of a project that we plan to continue working on. So thank you.
Thank you.
Great. We'll move on to the next presenters. Next up is Payton, Jiwon, and Anna, the team behind Call Code Response, who have engaged in a participatory design process with an Los Angeles-based youth theater production to co-create projection mapping effects using P5.js.
Hello, and thank you for joining us today. Our project Call Code Response is a part of the Processing's new fellowship, in which we use projection mapping to support a live theater performance in LA. This project, which is still in progress, aims to produce a groundbreaking hip-hop theater production that uplifts youth voices, integrates multidisciplinary art forms, and celebrates the cultural vibrancy of Los Angeles through the lens of hip-hop culture. Throughout this highly collaborative process, the three of us have worked with high school students and 4 organizations: Unusual Suspects Theater Company, Street Poets, Noisy Props, and Versatile. This project engages high school students aged 13 to 19 in a 3-phase process. During phase 1, while we waited for the story and script to be developed, we focused on introducing students to coding concepts and projection mapping so that they could provide informed feedback and suggestions on our approach. We also began scaffolding our technical system, gathering hardware and prototyping our implementation for the live production. We're currently wrapping up the production phase where students have been rehearsing their play. Here, we have developed the visual for our projections, tested our projections on site, and have continuously collaborated with community partners to coordinate technical theater elements and projections. Finally, the finished play and projections will be soon performed before a crowd of about 200 in LA. The play that students have created is entitled Live from LA, and it centers on a group of teens who rally their fighting community to save a beloved cultural center from gentrification in an LA Latinx neighborhood. The action is set against the backdrop of a community endangered by racial, economic, and political violence, and generational conflict concerning how one should respond to attacks against their community. The students have engaged in a creative process with critical thought and vulnerability, as they have crafted the script to reflect their personal stories about themselves and their loved ones, and drawn from historical social movements and thinkers.
And we use projection mapping to ground the play's action in historical and cultural context. As the characters grapple with the current political moment and threats against their community, We provide visuals made of related political imagery that invite the audience to draw connections between the present and the past. We aim for the audience to feel the weight of this moment, not only through the experience of the characters on stage, but also through the legacy of the generations who came before them. And there are three central themes guiding our project: remixing, splicing, cutting, and amplifying historical protest imagery against the novel ideas and messages presented by the students. Second, call and response. This involves being in constant dialogue with one's community, history, and environment. We've provided calls to the students, and they've responded by providing thoughtful ideas and images that reflect their personal experiences and sources of inspiration. Lastly, our work builds on existing community-oriented design frameworks, centering the perspectives and desires of high school students. We've remained accountable to these students, beginning this process by soliciting their ideas and continuously asking for their feedback. Students responded to us with activists they admire, slogans and chants that inspire them, and the LA protests and movements that resonate with them. In turn, we responded by developing projection visuals that directly use the references they shared. We deepened our participatory approach by working directly with one student who volunteered to get more involved in our technical process. For the sake of this presentation, we'll refer to him by his character name, Jorge. Since Jorge didn't have prior coding experiences, we designed a custom curriculum to teach him how to code in P5. For our one-on-one sessions, we developed a novel collage tool shown on the left-hand side, a visual interface that allowed users to arrange images directly on the screen while automatically generating the underlying P5 code. As images were added or edited, the P5 code was generated in real time, allowing users to create their collages outside the tool. Our curriculum for Jorge was based on the concepts that appear in the code generated by his collages. For example, we explained how he would go about uploading and transforming images, as well as how to use basic functions in P5. Our goal was to ensure that he not only understood how the tool and collages were made, but how he could use P5 moving forward. We used TypeScript to create our own collage tool and React to create the user interface components, such as buttons and the code editor. Then we used P5 to create the canvas, which included developing the ability to mask and edit images. Finally, we hosted our editor on GitHub pages to make it fully open access. Each collages can be exported as a zip file, preserving the raw data so we could reuse and remix them for the final visuals. Using this tool, Jorge, other students, and collaborators created protest collages that we later remixed them for the official performance. So later during our Q&A session, we'll be happy to delve deeper and answer any questions concerning the collage tool.
The control interface that we will use to cue the multi-screen collages and animations during the play was also developed from scratch. In our system, we developed custom data structures to define and trigger the cues. And these cues are defined as initial and final animation parameters exposed in our custom shader. We also mixed custom shaders to create animations that directly use the still images from the collage tool that Jiwon was just describing. The user interface for the control system was developed completely in JavaScript, while the rendering was done with P5. And then finally, we developed our control interface to display and combine P5 animations and videos created outside of P5. So essentially, we developed the control interface so that we could easily synchronize our projections with the live performance. We use one browser to render our projector on site, and we use open source tools like OBS to send our web collages to the projectors. And we then connect to a local network and use WebSockets to trigger the scenes across all of the browsers. For the play, our projections will accompany 2 scenes, but here we will only focus on the final climatic moment. In this scene, young members of the community stage a protest during a press conference discussing the city's plans to gentrify the neighborhood. The protest begins with Jorge, a nerdy hacker, projecting his artwork on the neighboring neighborhood buildings. Then, a song is performed by a young rapper from the community, where the phrase, "We're still here," is emphasized. As the song ends, a young girl performs a poem about the resilience of the Latinx community, growing flowers through concrete and bearing ripe fruit with history. Here, we have flowers growing from collaged images growing from the crevices of the buildings. And then another young woman takes the stage to deliver a moving speech detailing the power of those who dream, dance, and soar despite it all. During this, the flowers have blossomed into a large, powerful one and morphed into a butterfly large enough to carry the community to safety. And finally, the crowd erupts into chants shouting, "We're still here," while honoring Mrs. Vidalia, a woman who has recently been disappeared. The scene ends with the sound of police sirens disrupting the chants. The music halts abruptly and the crowd flees, leaving the stage empty except for the glowing projection still flickering defiantly against the buildings. Before we end today, we do want to emphasize a few key reflections and takeaways from this design process. So firstly, our projections were just one element of a production that brought together 5 organizations. While projections were our main focus, they weren't at the center of the play itself. This meant our work had to integrate smoothly into a bigger effort rather than standing alone. So we created the collage tool right at the beginning as a way to scaffold the design and technical development. This gave us the flexibility to prototype, test ideas, and adjust as the creative process unfolded without forcing the technology to be the centerpiece. And it also meant that we could stay responsive while still keeping pace with the project. And to be clear, the collage tool wasn't about making something polished or perfect. It was about quickly experimenting with aesthetics and technical ideas. By having this space for fast prototyping, we were able to evolve concepts in real time alongside the scripts and rehearsals. And reminder, the script was being developed as this process was happening. And because so many organizations and students were involved, everything had to be in motion at once: script development, rehearsals, feedback, and technical design. The collage tool lets students and collaborators engage in the process early without slowing down the more complex technical build. And the final component of this is the fact that we established a visual structure early on, so that contributions from students and community members all fit within a consistent aesthetic. And this approach was rooted in social practices and familiar visual language, which made the involvement feel authentic and cohesive. As a reminder, the official Live from LA play and projections will be performed next week, first for a community showing and then for a public audience. Until then, we are finalizing our projection animations and coordinating with the students and other facilitators to ensure all elements of the production blend smoothly. Thank you for joining us, and we look forward to hearing any comments and questions during the Q&A session.
Thank you so much. I am very, very excited to see this in action next week in Los Angeles. And yeah, if we have a link to the public presentation and folks are in LA, we'd love for you to check it out. Great, thank you so much. We'll move on to the next presenter, Kate Sicchio, who has created a new tool called P5 Score. It uses P5.js as a tool for choreographic creation, generating visual iconography through code to support a dynamic interactive performance environment. By framing coding itself as a choreographic process, the project brings computational tools directly into the dance studio. All right, Kate, go ahead.
Hello, I'm Kate Sicchio. I have a background in live coding, do a lot of other things with dance and tech, motion capture, wearable technology, a lot with robots. But today I'm specifically talking about algorithmic choreography and my project P5 Score. So just to give a quick definition of what I mean by a choreographic score, I'm interested in this idea of a set of instructions, guidelines, or tasks for a starting point for improv or for generating movement. So this could be written or drawn, it could be analog or digital, but it's a way of starting a creative process. It might also even document a process. But it's different than, say, like notation or Laban notation, and that's not really what this project is about. This is an example of a choreographic score by Camille A. Brown, a well-known American choreographer, who, in this score you can see there's lots of shapes, right? And there's squiggles, and there is some annotation, right? But it's mostly like words like diagonal, right? So there is this sense of like, it's not complete, right? but it is indicating a dance. So P5 score was looking at how to create choreographic scores like this that allow for affordances that computers give. It's designed to make dynamic visuals through animations. It can be used to generate movement patterns, spatial patterns, improvisation in live settings, notation of choreographic work, or whatever else you can think of. And it aims to give algorithmic patterns, generate new ideas, or randomize elements. One sort of thing that ended up being a guiding principle to this is that simple things lead to complex things. So the API itself is quite pared down, quite small, but by building upon that, you are able to create something bigger and more complicated. So the library itself uses a class called Dancer, and then you can give that dancer location and movement parameters. So you can give it a coordinate for a starting position, you give it timings for how long a movement should take, you give it the next position of coordinates to go to, and then you can also change the color or the shape of that dancer. Another large, this is just an example of what that might look like in P5, right? So you have these positions that you're going to. There's also built-in stage directions. So this was something that came up with users needing, like, instead of giving actual X and Y coordinates, just saying center stage was a way of getting the code dancers to move around. Another part of this project was building this in community. So we did a 2-day workshop in Richmond, Virginia, where I'm located, where we had a group of about 10, mostly choreographers, a few creative coders come, and basically workshop different ideas of how they could make scores with this tool. So we had various ideas in terms of, like, oh, if the here's one where if the ball is shaking, the dancers should move more. When it settles down, they move less. And then here's another one where they're moving through the location by following the lines that the dancers are making on the screen. This one was, like, clearly more immersive. The other one was more intimate and small on the floor. So lots of different approaches from lots of different people with different coding backgrounds. So some people who had never coded before were able to get into this and actually start using it in their choreographic practice. And that was a big sigh of relief from the workshop, that this actually was something that other choreographers were interested in using and could see how they could apply it in their practice as well. So we're going to do a little demo now. So I have a dancer here with me, Jaden Biden, who's going to actually perform a score that I made using P5 score. Thank you so much, and thank you to Jaden.
Yeah, make some emoji noise, some noise in the chat for that performance. Fantastic. I'm going to pass it over to Roxana to finish up.
I want to thank everyone for joining Open Assembly today. It was a really, really fantastic group of projects. It was so inspiring. And by the way, I'm Roxana Haddad, and I'm one of the co-executive directors of the Processing Foundation alongside Sheen. We want to give a very special thank you to the mentors who provided guidance to the Processing Foundation Fellows and to the Google Summer of Code contributors, as well as the PROS grantees. We want to thank Data Garden Collective, Gray Area, Interactive Fiction Technology Foundation, Unusual Suspects Theater Company, the Arab Image Foundation, the MIT Open Documentary Lab, and the Music Center. These are the mentors that helped made all these projects possible, and we are so incredibly grateful. For everyone who joined us today, we invite you to stay connected with us via Discord. The link in the chat will send you to an Open Assembly general chat on our Processing Foundation server. I know we got cut off speaking in our breakout group, so this allows us to keep the conversation going and keep talking about the possibilities and what is so exciting about the work we saw today. If today inspired you, consider making a donation. Your support directly funds early career artists, educators, and engineers building the future of open source creative coding. Recordings of today's presentations will be available soon. We'll let you know when they are ready via email. I also want to thank the amazing staff at the Processing Foundation. There was so much work that was put into this, and it was really a really incredible final performance from all of you. I was really inspired and am very moved by what I saw today. Thank you all for joining, and we really hope all of you have a wonderful rest of your day.